Hey y'all, today I'm going to talk about the applied project which is a DSL for climate data visualization. I already talked about the problem statement and what is a DSL, real world DSL examples, advantages and disadvantages, what is data visualization, how important it is, and raw data, NetCDF file, how it looks like, and main use case, sequence diagram, class diagram, DSL design in traditional and proposed way, and proposed DSL architecture in my previous YouTube video. In this video, I'm going to talk about in deep and the coding wise, the folder structure, and I'm going to run few modules and I will show you how it works. So in folder structure, I have a few. This is my main program, main folder, and I have input, libraries, module, output, source, and cdv.py. So I will explain all the sections one by one. So input file, I have all the real data, WRF files. These are all real data, and I have libraries, colors.py. I'll explain that later. And all the in future, if you adding more libraries, more external and internal libraries, all libraries should go under this libraries folder. And the modules, all the modules, and in case if you have enhancing modules, you can change these Python programs, or otherwise you can add more modules under this folder. And all the source files goes under here. And let's talk about all the modules, but before even going there, I will explain my main program and test and how it runs. So I'm using Ubuntu in my virtual machine, and also I'm using Jupyter Notebook, and all the modules, all the necessary softwares, libraries and tools are installed in Ubuntu. And let me show you my project folder in Jupyter. Here's my project folder. As I told you, all the inputs files are here. All these are the NetCDF files, all are real data. And here's a library. I have colors library. I'm using this library to differentiate print options such as errors, warnings, informations to. So I have different print statements, so I'm using colors to differentiate those. And then I have modules. I will explain that one later. And output files, or if the module is generating any output files, all the output files goes under this folder. And all the source files, the user is going to create the source files by using DSL syntaxes and grammars, and all the source files will be here. And this is the main program, cdv.py, which stands for climate data visualization Python program. And this is the main program. The entire DSL is handled by this program. So this program is smart enough to identify all the syntax errors, whether the input folder is there, whether the input file is existing, all the parameters and variables are provided or not. And if there is any error, it will provide meaningful domain specific error message in different colors. And all the information messages are there. And this program has a debugging option. If you enable the debugging mode, then it will provide all the informative messages as well. And in this program, it will go through all the arguments and get the module and load the module and import all the modules, and use all the parameters, variables, and call the module. And it will call respected module based on your source file. So I will explain one by one. Okay, so I will explain the quick plot first. So quick plot, here's the thing. So here's the module quick plot, and see this many code you need to do a quick load. What basically it does is you just need to provide a variable, one variable, and based on that variable it gives all the necessary information, all the relevant information, and making a plot based on that. So the domain experts, they know what are those variables. Those variables are there in their input file. So I will show you the source file. The source file is this. This is the only thing the users needs to create. So whoever is using this DSL, they needs to create this JSON format option, format source file, and that's it. So the type is mandatory, file is mandatory, this input file, and debug option is there whether true or false. And then in quick plot they needs to provide only one variable, and it is only supported for one variable, and they can provide the variable and get the output. So I will show you how to run it. So let's see. There you go. We are going, yeah, we are plotting T2. So is a temperature, is a description is showing, is a unit is showing the Kelvin, and the dimensions, variable type is numpy array, and variable shape and all, and generating the quick plot, and here's the graph. So it is so easy. Otherwise, see, because of this DSL, it is easy for them to create this kind of graph. Otherwise they need to create all the data, all the coding, and need to handle all the errors, exceptions and all, and also need to check whether the output is right or not. So by using this DSL, so they just needs to create a source file and use any modules. That's all. So I will show you the sounding plot as well. Here's the sounding plot. Let me go through quickly the sounding plot module, and here's the thing. So it basically needs, see how big it is. If you don't have this DSL, you need to create this many code and need to do all the calculations and all, and need to test everything and all. So I'll quickly show the sounding plot. Source file, here's a source file, and need to provide base pressure, normal pressure, Q vapor, and temperature, and parameters are optional. You can provide those to get better output. And let me run it quickly. Okay, it's not the one. There you go. So this is latitude and longitude 4830, and this is a sounding plot. And so it is so easy for DSL users. Just they didn't need to create this. They only need to have a proper understanding of about that domain, and proper understanding about this file and all the variables, and that's all. Rest of the thing will take care by this DSL. And I will quickly run the total pressure as well. Here the total pressure, and we are using PMB, uh, perturbation pressure and base state pressure. So let me show you the source as well. Here is the source. Just needs to create these, needs to provide these variables, and these parameters are optional. And I will run this one quickly. And there you go. So total pressure, here's it, and millibars. So see how simple it is. It just needs to create this source file, and that's all. And likewise there is another module called wind speed, and they need to provide this information and will create that. And in future definitely we can add more modules and enhance this one with the more proper syntaxes and all. And that is my intention. So that's it in this video, and thank you. And if you have any questions, please feel free to create a comment on my YouTube link. Thank you.